Hello, so today we are going to do problems from weekly contest 390, this week's weekly contest. And the third problem is most frequent IDs. So basically, we track the frequency of IDs in a collection that changes over time. And basically, we have a list of numbers, and we have a frequency array that represents at any point in time the frequency of the number at that index. What does that mean? So for example, here at step 0, right, step I is basically the indexes that we are looking at. And so for example, at step 0, right, we have 2 3 times. So the frequency of I, that's the frequency of the number at position I. Okay, and so result, at any point result returns the max frequency for all elements. So for example, position 0, we have only 3 of value 2. And so we put 3 here. For step 1, we have 3 2 times. So we have 3 2 times and 2 3 times. So the max frequency is still 3. For this 0 1 2, for step 2, we have 2 but minus 3 times. So that cancels out the 3 that we had initially here, right? And so now we have 0 2s and 2 IDs of value 3 and 2 3s. So now the maximum between 2 and 0 is 2, and so we put 2 here, and we keep going until the end. But that's the idea essentially. The constraints are quite big, both for the length, for the number of values themselves, and for the frequencies. So that makes it trickier, right? So let's see how we can tackle it. Okay, so let's see how we can do this. So we need to keep track of the frequency to know the highest one, right? So for a frequency, you could use either a hashmap or a counter in Python. We'll use a counter in Python just since it's easier, but you could use a hashmap if you are using another language. Okay, so this is just to keep track of the frequency over time at each step. The other thing we need is at each time we need to get out the maximum frequency, right? But the problem is if you use counter, you can use a most common function, but that one is linear. You could also just go through the counter and find the maximum frequency, but that's still O(n). So this is not something that we can use because it's O(n) time. Because we are going through already the array in O(n), if we add another O(n) underneath it, that will be O(n) squared. So we can't really do this solution. So what can we do? Well, what's something that can get you the max out efficiently? Well, a heap Q, a min heap or a max heap can do that. In our case, we want the max, so we want a max heap. So we can use a heap Q in Python, or in other language, you can just use a priority queue. In our case here, we need a max heap, but in Python, you can use a max heap by just adding, for the frequency, adding it negative with minus, so that when you pop it out, you will get the smallest element, but the smallest negative element is actually the biggest element. Okay, so we need to use these two, but how do we coordinate the fact that sometimes the frequency is negative, right? Sometimes the frequency is negative, which means basically we are decrementing the frequency. Okay, so if you are decrementing, and sometimes also it's positive and you need to increment an existing frequency. But we already added to the heap queue, so our trouble here is how do we update the heap queue, right? How do we update the priority queue? We could go through the priority queue and find the element with its frequency, remove it, but then that's O(n) as well, so we can't do that. But if you think about it, for the heap queue itself, we don't care about all the changes of all the elements. The changes, we already keep track of them in the counter. What we can do is actually each time we can just check the top of the heap queue and see if it matches the counter. If it matches the counter value of the same top of the heap queue, if it matches it, then we are fine. But if it doesn't, we can just pop the top and add something that matches the counter, and keep doing that until the top matches the counter, because for that step we will only extract the top. Okay, that's the key idea here, because the top is not going to be that doesn't match, is at most going to be 1 or 2, because we keep updating it, right? And so, and overall it's not going to be in total, it's going to be O(n), because we are able to add only O(n) elements, right? And so that's the key insight. That will make it not O(n) squared. So we only check the top. That reduces the time that we need to solve this with. And we only pop and update with a new value if it doesn't match the existing value in the counter. Okay? And that's pretty much it, the key insight. And now we can code it up, and you have to be careful with the code, but that's the core idea. Okay, so let's code this up. So first we said we need a counter to keep track of the frequencies. So let's just have that. And just to make it like this, easier to write, we will make this A. Okay. And now what do we need to do? Now the next step we need to do is go through the elements in the array, right? And so we need to do in range of n, and we need to define what n is, which is just the length of the array, like this. And then we want each time to increment the frequency. So now we are at step I, which means we need to set the result at I. But we also need to initialize the result array that will return at the end. Now remember, the result is going to be just for each step, and we have n step, right? So this is going to be range of n, and this is what we are going to return at the end, okay? Now for each occurrence, remember, this is the frequency has the values we want to have for that number. So for 2, we want to have it 3 times. So we add the frequency to the frequency table that we have. Okay, so now is where we need to push it to our heap queue, so that if it's the highest element, we want to pop it out later, right? Now you might say, okay, what if we already added an element with 2, and now we are adding it with the new frequency, let's say it's 3, now we are adding it with 5. But that's not a problem, because the second one, we will pop it out when we find that it's not equal to the current value of occurrence. You will see that in a second. And so here in our heap queue, first, we also need to define our heap queue, which initially is just an array. We want to push the frequency, which is just the occurrences of A of I, and then the element itself. But since this is Python min heap, we need to do -1 just so that we get the max value out. And now this is where we update the heap queue to match top value to match occurrence. And so we do that, we keep doing it while the occurrence of the top, what is the top value in a heap queue? Well, it's just the first position. Now we want to get the number of occurrences of the value in the top of the heap queue. The value is at position 1, the frequency is at position 0, and so we want the value. But we want to check if so this is the actual source of truth of the frequency. But we want to check if it matches what's in the heap, because the heap, we don't keep it updated. We don't keep the entire heap updated, we only keep the top element. And so here we want to check if it matches the value, the current frequency, which is the one at the first position. But remember, we already added -1, so we need to cancel that -1 out. Okay, so the value itself, let's call it A, is just 0, 0, right? Okay, and so we want to pop the current top because it has an out of date frequency, and so we want to pop it out, get rid of it, and we want to add, so basically this here, top is obsolete, or let's call it actually has obsolete frequency because it's different than the actual source of truth here, and so we want to remove it and add we push it again with the actual correct value. So how do we do that? Well, the correct value is A. The correct value is the same regardless, but the correct frequency is this, right? The updated frequency is this. We need to add minus again so that it acts as a max heap, but this is the core idea. Okay. Now, once we exit this, we should be fine. Once we exit the loop, because that means the top now has the correct value. And we can, here for res I, we can set what should be res I? Well, it's the maximum frequency. Now, what is the maximum frequency? Well, that's just the top of the heap. We already make sure that the heap is updated, the top is updated. So we are guaranteed that the top now has the maximum frequency. So how do we get the maximum frequency? Well, it's just the first position of the first value of the heap. So the first value of the heap is here. The first position is the frequency, but we need to cancel out the minus that we add. So we cancel that out. And that's pretty much it here. So if we run this, except here this needs to be n, and this needs to be frequency of I, sorry. So there's actually a small mistake here. So the value itself is not in position 0. The position 0, we have the frequency. The value is in position 1. So that's just a small mistake here. And that's why we need here, let's just call it just what we put here. So we actually don't need, initially we want it empty, right? Because we want to take into account only the values at each step. That's what the problem asks us to do. Here, for step 0, we want to only take into account element 0 and frequency at 0, right? So we want to keep this, initialize it empty first. And now if I run this, it should be good. And it is. I guess accepted. Now one thing I want to mention here is you may ask yourself, why not do if here instead of the while loop that we had? Well, we do while because once we update with the updated frequency, because this may have been a decrement, right? It could have been a decrement. And so this one here would not be the new top, right? So maybe a new top is another array value. Now in that case, we don't know if that array value was updated before and is no longer up to date. And so we check it again so that we make sure it's up to date. So this loop makes sure that the top of the heap always has the right frequency that matches what's in the occurrence. Okay, so that's the idea behind the while loop. Now let's just go through it again. Looks good. Now, yeah, so that's pretty much it for this. Initially you might think it's tricky, but the key insight is you don't actually need to make sure the entire heap queue is updated at any point in time. You only need to make sure the top is updated, the frequency for the top is updated. If it's the max and it is updated, then we can use it as the max, right? So that's the idea. And as long as we keep updating the top, right, the entire heap queue will be updated, will stay updated. And so that's the key insight here. Yeah, so that's pretty much it for this problem. Thanks for watching and see you in the next one. Bye.